Hello, this is the fourth film of 8 about mole calculations. Films 4 to 8 all deal with stoichiometry, so that is calculations that are based on balanced equations and the mole ratios that we can get from them. And we're going to start off by looking at calculations that involve mass, because most people are more familiar with mass calculations than they are with others, so this is probably a good place to start. Okay, we're going to refresh our memory of the equations that we use to convert mass into moles, and we're going to do a couple of practice calculations. Alright, here are the most important symbols that we use when we're dealing with masses, and a couple of equations too. Alright, we've got the three symbols that end up in the equations. They are the number of moles, the mass in grams, and the molar mass. Remember, this is just the mass of 1 mole. And I suppose it's worth mentioning at this point that you need to be able to convert other masses into grams. So for example, if you're told you've got a kilogram of substance, then that is 1,000 grams, and a ton, that's 1,000 kilograms, so 1,000,000 grams. So you need to make sure you can do those conversions. Okay, some people like to have a triangle in their mind for these formulas where they have things set out in it, and they just cover up the one they want to find, and the triangle tells them what they need to do. But if you prefer to memorize formulae, or you can just figure them out, then all well and good. Let's go on to an example calculation, and let's have a careful look at the balanced equation before we start. This question is asking us to relate the oxygen to the NaClO3. Okay, so let's just highlight those two things in our balanced equation and see what the stoichiometry is like. That is to say, the mole ratio that we can see in the balanced equation. Right, well, we've got 2 moles of this to every 3 moles of oxygen. So I know that if I can find the number of moles of this, I'll be able to find the number of moles of that. Okay, I would suggest that a good way to start on all of these questions is to write a formula for the thing you're being asked. Okay, how many grams of O2? That is a mass, and the mass equals the number of moles times the molar mass. I can always find the molar mass of a substance if I know its formula from the periodic table. Okay, so this really is a question of finding what is the number of moles of oxygen. Well, as we've just said, that's related to the number of moles of sodium chlorate. Let's just write an expression for it, saying the number of moles of oxygen is equal to the number of moles of NaClO3. Okay, now is that true? Well, no, it's not, right? Because there's 3 moles of oxygen to every 2 NaClO3s. Is there more oxygen than this? Yes, there is. So I've got to put these two numbers one over the other so that the number of moles of oxygen becomes greater than this. So the number of moles of oxygen, if it's going to be greater, must be 3 over 2 times as large as that. Okay, rather than 2/3. 2/3 would be wrong, because then I'd have a number of moles of oxygen that was smaller than the number of moles of that. Okay, so let's go ahead and have a look at this. The number of moles of oxygen is 3/2 times 12 in this case. So 3 over 2 times 12, which equals 18. So the mass of oxygen is equal to 18 times the molar mass, which is 32. And let's just quickly find out what that is, which equals 576 grams. Okay, so we're starting simple there. We're told the number of moles of one substance, and we're just turning that into the number of moles of the other and using that to find a mass. Here, we're told how many we're asked how many grams of sodium chloride now. Grams of sodium chloride are produced when 80 grams of oxygen are produced. Okay, let's just look at the mole ratio of sodium chloride to oxygen here. It's also 2 to 3. Okay, let's start by writing a formula for the thing we're asked. That is the mass of sodium chloride. Okay, if you can make your steps of working clear, then you can get awarded marks even if you get your final answer wrong. If your working isn't clear, then you're not going to get the marks on the way through. The mass of sodium chloride, that is equal to the number of moles times the molar mass. I can always find its molar mass from the periodic table. Let's see how the number of moles of it is related to the number of moles of oxygen. Well, the number of moles of sodium chloride is related to the number of moles of oxygen. But how is it related? Well, there's less of it than there is of oxygen. So 2/3 rather than 3/2, which in this case, I don't know yet know. So I've got to find the number of moles of oxygen, the number of moles of O2. I know a formula for that. That's little m over big M, which in this case equals 80 over 16. 80 divided by 16 is 5. Should be able to do that in your head, but I didn't. And so we know the number of moles of oxygen. So we know the number of moles of sodium chloride, because 2/3 of 5. So the number of moles of sodium chloride is 2/3 times 5, because that's the number of moles of oxygen, which is 3.33. Okay, and finally we just say that the mass of sodium chloride is the number of moles times the molar mass, so the mass equals 3.33 times what's sodium chloride. Look them up in the periodic table. It's 22.99 plus 35.45, is it? Yeah, 45 chlorine, and that equals, so 22.99 plus 35.45 equals, and then multiplied by 3.3333, and that equals 194.8 grams. Okay, so there's 2 stoichiometry questions done for you there. Here's another one using a different equation. Let's just quickly rattle through this because we know the principles now. Right, we are dealing with a reaction in a blast furnace. We're told we've got 25 kilograms of Fe2O3, 25 kilograms of that, and we're asked how many kilograms of iron can we form. This is a question that is asking us the mass of iron. The mass is equal to the number of moles times the molar mass. Okay, I don't know the number of moles yet, but I do know the molar mass because I can look it up. So let's just think about whether the number of moles of iron is related to the number of moles of the thing that we're told about. Okay, so is the number of moles of iron, which is 2, related to the number of moles of that? Well, yes, it is. They're not the same though. Okay, so this statement doesn't make sense. The number of moles of iron, 2, is twice as large as 1, so this has to be 2 over 1, because 2 is twice as large as 1. Right? It's not half as large as 1. Okay, so let's find the number of moles of Fe2O3. Well, that equals the mass over the molar mass, which is 25,000, because we've got 25,000 grams, divided by 2 times 55.85, added to 3 times 16. Okay, so we'll find the bottom first. Okay, so that's 2 times 55.85 plus 48. That's 25,000 over 159.7. Okay, 25,000 divided by that, so equals 156.5 moles. Okay, so we now know the number of moles of Fe2O3. We know that the number of moles of iron is twice that number, so 2 times 156.5, which equals 313. So we've got 313 moles of iron, so the mass is 313 multiplied by 55.85, which is the molar mass of iron, and that equals 17.5 kilograms, or 17,500 grams. Okay, so there's my final answer. Okay, I suppose I've gone zigzagged a bit. Okay, I've not gone down in one sequence of steps because I ran out of space on the page. Okay, but every time I'm doing something, I'm writing an expression for what I'm trying to calculate. So try and get into that habit to make your working clear. All right, as usual with mole calculations, the same old message. Practice it regularly. If it's hard, you're not ready for a test, so try and get some help and do a little bit more practice. There are so many mole calculations based on mass stoichiometry out there. You've just got so much stuff you can practice. So get some practice in.